authorization. Once again, if you've got a cell phone, we'd appreciate your turning it off for the session. And don't forget your session evaluations. Our first speaker is Alexander Otenko, and he will be presenting to us the Permis Framework. Alexander is from the University of Salford in the UK. He's a postgraduate student at the University of Salford and responsible for the implementation of the RBAC Authorization System and working under the guidance of David Chadwick, which I'm sure a few of us know. So, Alexander, if you will. Thank you.
Good afternoon, ladies and gentlemen. Today I'm going to talk about access control and privilege management and where 2 years of our research have led us to. Professor David Chadwick is supervising our research, is giving a similar talk at the ACM conference in California at the moment. So if you have been to his presentation, you might find some discrepancies between what he says and what I am saying, because he's a project manager and I am the implementer. So what will... how do you switch? All right. How do you make it full screen? There you go. All right. So we will start with the traditional way of controlling access, and then we will move on to the new technology and what we are offering as a result of our research. So traditionally, each application had its own list of usernames and passwords and an access control list. So it was really easy to code it, that's why it's so widespread. But it was really confusing for users to remember all those passwords when they're accessing several systems. For example, I have a username and password for accessing my email account, and I have a username and password for accessing my network drive, and I also have some username and password for Athens network, whatever it may be. But I remember just only the password that I use most often. And it was solved in our university in the following way. The administrators just put a password.txt file in the root directory of the network drive for each user. It's more user-friendly, but it's not that secure. And the other problem is that when you add another user to the system, to the distributed system, or you want to remove a user, it becomes a real hassle for the administrators to allocate or revoke privileges that the users have got. So there was introduced public infrastructure to make users happy. The users now have to remember just one password for accessing their private key, and the infrastructure provides any application that wants to authenticate the user with a public key certificate that binds the user and the sign-in mechanism. So when a digitally signed request comes across the network, an application can figure out that it has originated from the particular user. However, this system doesn't solve the problem of administrating, because still the applications have access control lists, and that is still a problem. So they introduce now a privilege management infrastructure. Inside this infrastructure, there's a set of authorities that issue users with privilege certificates, digitally signed tokens that give users particular, that authorize users to perform particular actions on targets. So now it becomes really easy to establish, really easy to administrate. The administrators just have to establish trust relationship between the application and the privilege management infrastructure. And the real privileges are allocated by the authorities of this infrastructure and is done once and for all applications. So it becomes easier to administrate, so you just issue one attribute certificate and it's used everywhere. So now we have happy users and happy administrators. However, we have unhappy programmers because this infrastructure is really difficult and complex to code. Are you curious about the next slide? No, it's not just another infrastructure. It's an access control framework. This standard defines how any access control system can be divided. So we have an initiator, which is a software that works perhaps on behalf of a human user that submits access requests to a target. And between them, there's a gatekeeper that intercepts such requests and makes decision if access can be granted or not. And if access can be granted, if the policy allows that, then then the gatekeeper forwards the request to the target. If the policy does not allow such access, the gatekeeper just drops the request. Further on, the framework divides the gatekeeper into two parts. One is access enforcement function, the AEF, and the other one is access control decision function, the ADF. They cooperate in the following way. The AEF authenticates a user and forwards the decision request to the ADF block. And the ADF just returns a decision, true or false, granted or denied, and the AEF enforces that decision. That's where the programmers become happy, because now we can define an interface between the two blocks, and we can write just one universal ADF that can be used everywhere and can be plugged into the gatekeeper and can be used by the AEF. So rivaling research groups have got their own standards. So we have got now Open Group's AZN API and IETF's GAA API. Both of them are talking about the same interface between the access enforcement function, the application-specific component, and the ADF, the decision block, which is application-independent. When we started our pan-European Permis project, we could not find any implementation of any of these APIs that would let us use X509 attribute certificates. And the pseudo-object-oriented approach that these APIs are using, we found somewhat confusing. So in terms of Permis project, we have defined our own API, Permis API. It's pure object-oriented and it's written in Java. And we have got implementation that is working with X509 attribute certificates. So now the system will look like this. An initiator submits a signed access request to the gatekeeper. The AEF verifies the signature using PKI and submits and forwards the decision request along with the name of the initiator to the Permis API implementation. The implementation will pick up privilege attribute certificates and the policy from an LDAP directory, and it will verify the signatures on the certificates to ensure that they were not forged and that they are not corrupt. And will make a decision according to the policy and will return true or false, granted or denied. Then the AEF will enforce that decision and either forward the request to the target or send an error message to the initiator. So what we offer is the components of the PMI, such as the Permis PMI implementation, that is the ADF block, the decision block. And we also provide you with a tool, privilege allocator, that lets the administrators create attribute certificates, either for assigning privileges or for creating policy attribute certificates. And we also provide you with XML DTD that defines syntax for the policy, which is written in XML. And when you provide us with the XML of the policy you are going to enforce in your target domain, the API will understand it. And what you have to provide for the system is the access enforcement function, which will communicate to our API implementation and will enforce the function, and the PKI that will provide us signature verification facility. Then your happy administrators will have to write an XML of your policy and embed it into an attribute certificate. And you will have to provide an LDAP directory where the attribute certificates will be stored. Inside, our policy introduces role-based access control. To the contrary to the traditional way, where we had user names and passwords and access control lists, which is discretionary access control. In this model, there is an intermediate layer of entities introduced, the roles, and this concept describes the structure of organization more clearly. So in this case, you don't assign privileges directly to the users. You assign privileges to the roles that exist in the organization. So if a team leader needs to read files, you assign a privilege to the team leader and not to the particular user. And if a project leader needs to delete files and sign orders, you assign these privileges to the project leader, not to particular users. And after that, you assign users to the roles just for the time that they're performing this role within the organization. In this way, it becomes easier to allocate and withdraw only as much privileges as is required to perform a particular role within organization. More than that, the roles can be related hierarchically. So a superior role inherits all privileges that are granted to its subordinates. And this is also reflects the actual situation in organizations. So I'll just skip this. Our policy XML, now we will have a look at our policy XML in more detail, how you construct the privileges, how you specify the rules. Our policy consists of two parts. One is role assignment policy, and the other is role specification policy. And we will go through these parts in more detail in a moment. The role assignment policy comprises such three components: the SOA policy that specifies who is trusted to issue attribute certificates, a subject policy, and a role hierarchy policy, which I will in a minute. The subject policy splits the users into domains by grouping them by their LDAP DN, the distinguished name of their entry in an LDAP directory. And after that, such subjects can be referred in the role assignment policy. For example, this statement says that there are two domains defined: companies and employees. The employees users are those whose LDAP entries are located in the subtree with the root DN specified over here. The subtree specification can be much more complex, but this is just an example. The role hierarchy policy specifies what roles are understood by this policy. Since they're just strings, there's no meaning in that. So you just define what strings you accept and what is the hierarchical relation between the roles. For example, this statement says that there are three roles understood by the policy: the tenderer, the tender clerk, and the tender officer that is superior to the tender clerk. So this is the chart of the hierarchy. So everything that a tender clerk has got, all the privileges that the tender clerk has been assigned, the tender officer will have, and the tender officer can have a separate set of privileges as well. Finally, the role assignment policy links all these policies together and specifies under which conditions particular users from the domains can be assigned particular roles. So in this statement, we see that any user from the employee's domain can be assigned a tender officer role by the Salford SOA. The SOA is defined by SOA policy, but we just skipped it. It also says that the users cannot delegate their role any further, and that the role cannot be valid before the specified time. This statement also implies that the Salford SOA can assign roles that are subordinate to the tender officer, for example, tender clerk, as we have seen before. And now we have viewed the role assignment policy, and now we are going to see what the role specification policy is. In the XML, it is called target access policy, and it comprises the following components. Target policy, it specifies the domains of the targets that this policy covers, and it is the domains of the targets are specified in a way similar to the subject policy. And action policy that specifies the granularity of access to particular targets. So you can specify read or delete or write file on the same target, and they will have different permissions for that. And target access policy may contain additional comparisons, but we don't have much time, so I'll just skip this. Target access policy links the three policies together. So targets, actions, and role hierarchies are linked, and the actual privileges of the roles from the role hierarchy are specified by this policy. For example, this statement says that a tender officer can delete anything from the store, or if you like to word it in another way, in order to delete anything from the tender store, you have to be assigned to the tender officer role. This role list specification can contain several roles, in which case you will have to possess several roles to perform particular action. And this is an example of condition statement, but as I said, possibly we don't have much time. This is just a statement that says that time of access obtained from environment must match a particular pattern in order for access to be granted. So that's the main concept of the policy. And you can write it either in your favorite text editor, because it's just an XML, or you can use a user-friendly tool such as Xena from IBM AlphaWorks. The tool from IBM verifies syntax, so you can be sure that your policy is syntactically correct and can be understood by our tool. And we also provide you with a privilege allocator. This tool is a front-end, a graphical front-end for you to create attribute certificates. You just input the LDAP entry, the distinguished name of the LDAP entry where the attribute certificate will be stored. Then you input the issuer, the serial number, and specify the period during which the attribute certificate will be valid. And then you input there either role assignment attributes or a policy attribute, the policy XML, and then it will be signed and stored automatically in the LDAP directory. So I'm afraid we don't have much time to go into much technical detail of the Permis API, so I'll just mention that we have got just a few simple-to-use methods that let you retrieve the roles that have been conferred to a particular user, and then you can use that set of roles to make a few subsequent decisions for several actions the user wants to perform. So this is just again technical. So just to put it all together, we will review how we think it will work. The PKI, the public key infrastructure, creates public key certificates to certify that the holder of this certificate has signed a particular digitally signed request, and stores the PKCs in a publicly accessible LDAP directory. And there's a privilege management infrastructure in place. The source of authority creates the privilege policy attribute certificate and stores it in LDAP directory, and then authorizes the users to perform particular actions by issuing them with an attribute certificate and storing it in a publicly accessible LDAP directory. So after that, when a user wants to access the protected application, he sends a digitally signed request, and the gatekeeper will verify that the signature is correct and thus will authenticate the user. So it will know who the user is and where his attribute certificates are located. This information is passed on to the Permis API, and we will retrieve the relevant attribute certificates from LDAP directory, and we will retrieve the roles for the user, and we can make access decisions for him. And possibly now you are starting to think of your questions because we are going to the end of the presentation. But the first question is mine. How much of it is done, and is it release quality yet? Well, it all depends what you want to achieve from it. Certainly we can include your requirements into our implementation and make release 2. But at the moment, we have implementation that is capable of handling 4 pilot projects that we are running all over the Europe. So there's Salford City Council application that is running electronic tendering system, and they want only specifically certified organizations to submit electronic tenders to their store. And that is where access control is situated. And there's Barcelona municipality who have certified certain car rental companies to let them access their car parking fines database to retrieve data about fines and update it. And Bologna Comune has got a database of city plan, and only specifically certified architects are allowed to submit changes to the building plans and city plans. And the other application is electronic prescription processing, which is already running, and the application is oriented to help pharmacists check that a particular patient have got a prescription and that he has been allowed to hold this prescription, and that the doctor who has issued the prescription attribute certificate has been allowed by a British Board of Health to issue such prescriptions. So that's the variety of the application of our API. And we are starting most of pilot tests in the middle of June after a technical meeting in Salford. So that is it. Thank you for your attention. If you have any questions, you can go to our site over here, and you can find emails of me and Professor Chadwick. And if you have further queries, you can email me or Professor. And now your questions are welcome.
Peter.
I wonder why you need the XML to put into an attribute certificate. As I see it, you just sort of misuse the attribute certificates idea, which was to define the attributes inside the certificate and not inside an XML structure that is just put into a bulk into the attribute certificate.
Right. If I understand you correctly, you say that the XML is misused there. Actually, we create just a policy as an XML, and the roles are issued to users as attributes in the attribute certificate. And in order to provide, to specify a policy, you have to define some structure that this is how roles can be assigned, this is what a particular role has got, and this is who are allowed to issue roles, to assign roles to particular users. So that is what XML is specifying. We could do it in SN1, but it won't be human readable. It would be easier for administrators to create an XML policy that would say, that would contain these statements, and it would be embedded in a policy attribute certificate to be tamper-proof. But the users are issued with attribute certificates containing, say, printable string value in it, saying that he has got a particular role. So that is how. Does that answer your question?
You have four examples of usage of that.
Right.
For these four totally different fields,
Mm-hmm.
you use one kind of attribute certificate. And the idea of am I correct in this?
Actually, there's two kinds of attribute certificates. One is role assignment attribute certificate, and the other is policy attribute certificate. So a role assignment attribute certificate contains just sets of printable strings saying, for example, tender officer. So the holder, which will automatically mean that the holder of this attribute certificate is a tender officer. And what he's allowed to do is specified in a policy attribute certificate, in the XML contained within the policy attribute certificate. And the policy is, and we chose XML just a way of structuring the policy.
Yeah, and well, I was thinking, why didn't you use a common information model to structure the policy, which would be inside the same realm, so to speak. You could just store them in an LDAP directory as LDAP entries and not just as an XML structure, which has to be interpreted by yet another technology and another set of tools and programs that pass the XML. I would think it would have been a more homogeneous construct if everything would have been in the ASN1 LDAP world.
If I understood you correct, you offer that the policy is separated into bits and is stored as entries in LDAP directory, is it?
Yeah, well, that's what I
All right.
would have
Right.
to store the policy in LDAP and not in XML.
Right.
So this
Why-
might be something that maybe you and
Yeah.
David Chadwick can discuss.
Yeah.
I think we have a...
I could answer this question. You see, we just found that LDAP directory cannot be trusted, so we have to embed it in a cryptographically protected entity, which we thought would be an attribute certificate. All right.
Okay, I think we have time for one more question, but if someone can turn on the microphones that are coming from the audience, that would be great.
I have a question about heritage.
All
You
right.
have this nice hierarchical system, and I noticed your example applications are all small, manageable, nicely hierarchical organizations. Have you tried applying your scheme to, let's say, a university, 20,000 students, 5 to 10,000 employees, nice mix of them both? People tend to have lots of roles, and if you have, what is the mean number of roles per user you end up with?
Actually, we thought of introducing the ABAC model for the university, but I think there's not that many roles that are in the university, because there's, if there's thousands of students, it's just thousands of role assignments. All right.
Okay. I think we have to go on to the next speaker. Alexander, thank you very much. That was great.
Thank you.
Our next speaker is Alan Robiette. He is going to speak to us about authorization models for national scale services and within the UK. Alan is the Program Director for Authentication and Security within the Joint Information Systems Committee, JISC, which provides national infrastructure and services for UK further and higher education. He's a physical scientist by training and pursued a teaching and research career in chemical physics for a number of years. He's moved into IT management, and he was an IT director for some 15 years, working in some of the country's leading higher ed institutions. So Alan's going to speak to us about various national scale services and authorization.
Well, thank you, Michael. Good afternoon, everyone. First of all, just for those who don't understand it, my organization, the Joint Information Systems Committee, or JISC, is essentially the parent organization for UKERNA. So we fund UKERNA to operate the national network, JANET, but as JISC, we also provide a lot of other value-added services which run on the network. It's a very similar setup to SURF and SURFnet in the Netherlands. Okay, well, this is really all about scale and the manageability of scale. Some of you will know that Terena has a task force now set up to look at authentication and authorization with a remit to look at requirements across different countries' networks and services to see how much common ground there is for moving towards a common architecture. We, in common with several other countries, are very interested in doing that, but our position is a little different because we already have a national scale first-generation architecture, and our problem is not to start from nothing and put in something, but to start from a very large installed base. And as those of you who run services will know, to remove an operating service and replace it with something different is one of the hardest things you can undertake. So I'm going to talk very briefly about the authorization problem, about why we run and why we're going to continue to need national scale services, about our present service, which is called Athens, and how Athens itself is evolving, to compare that with some of the other emerging architectures, which include Shibboleth, the subject of Bob Morgan's talk, and to try and pull it all together. Okay, very quickly, the authorization problem. I think everybody in this audience is familiar with that, and it's the same theme as we have all the way through these middleware talks. We assume that the user is authenticated, but when you start trying to determine their privileges, you need a way of describing attributes which users have. You need a way of describing what the use conditions or business conditions are for the use of the resource, and to make the access decision, the problem is to map one onto the other and say whether it's a yes or a no. Why do we need them in the UK? Well, for a number of reasons, but one of the things that we have is very extensive content services. Some of those are republishing academic content on quite a big scale, but we also have for some 10 years or a little more negotiated on a national basis with commercial publishers for commercial content. And those community-wide contracts apply potentially to over 600 institutions and potentially to a population of around about 5 million people. For any particular deal, it's up to any university or college to decide whether or not to sign up to that deal, so we need an authorization system to distinguish those who are permitted from those who aren't. And currently, we control that access either in the crude old-fashioned way by IP address checking, or, and preferentially right now, we ask the publishers to implement Athens. So Athens, what is it? It was originally developed by a team on one of our university campuses to provide a single ID, single password unification across a range of disparate services. It was then extended to cover our own data centers, of which there were then 3, and it's then been progressively extended out to commercial suppliers to run on their own servers. And the original team at Bath has now spun off to a not-for-profit company known as EduServe. There are 2 members of the Athens development team from EduServe at the conference, and so anybody that's really interested can talk to them and find out the inside story. So the original technology of Athens was, and this is something which dates really from the middle 90s, so we're going back a way. It was to have a centralized database out on the network of user IDs and passwords, each associated with a vector of authorization information, tracking that user across a range of resources and simply providing a yes-no decision on whether an individual was allowed to access a particular resource or not. Think of it as an enormous matrix. So in authorization terms, it's very, very fine-grained, but it's also rather labor-intensive to maintain. That database has devolved administration, so each university can log in originally. Now there's a web administration interface to manage the creation and the ongoing management of usernames and the authorization privileges. And it talks a proprietary protocol, essentially, to the database provider, the supplier server, for which there are software plugins. So it's kind of a complete trusted third-party model, not dissimilar in some senses from something like Passport. It has some nice features like the authentication dialog is all encrypted, so these passwords are reasonably secure across the network. And the central database is currently replicated at 3 different geographical locations on different parts of the network, so it does actually provide pretty good operational resilience. And the main thing about it is the scale. There are over 400 institutions in our education community that are Athens customers, plus, as of the last year or two, it's been extended to the National Health Service, so there's a growing number of hospitals and organizations like that using Athens for what they call the National Electronic Library for Health. There are over 1 million user accounts. We don't know exactly how that maps onto people because there are some problems inevitably in maintaining a database that size, and over 150 information resources controlled by Athens, with a whole range of major publishers. So Athens has been a success as far as we're concerned in allowing us to do a wide range of things which we couldn't otherwise have done. But no system like that is totally free of problems, and I'm going to talk about the problems, then I'm going to talk about Athens' plans for tackling those. The main architectural problem is that it is a third-party model. So the Athens user namespace is distinct from the campus user namespace. They have to be maintained separately. In fact, typically, you find that it's the librarians that maintain the Athens ID space, and it's the campus IT services that maintain the usernames on the campus, obviously. And that leads to lots of problems with data quality and data maintenance and so on. And it, because of the architecture, because it's a trusted third-party model, it militates against ever unifying the authentication and authorization technologies off-campus and on-campus, because you really don't want to use a service out there on the network for your own local authentication and authorization. And there's another problem in terms of the longer term, which is that the whole system is still a single vendor system proprietary to EduServe, but we have a constant dialogue with the company on that, and maybe we'll make some progress in the longer term. So Athens doesn't stand still, EduServe don't stand still. What I'm talking here about are the company's development plans, although as their largest single customer, we have quite a lot of input into those. They implemented a single sign-on facility that happened earlier this year, which remained something I would otherwise have described as a user barrier, that they had a single, in the old days they had a single ID and password, but they used to have to re-enter it every time they moved to a new resource. That's now been overcome with a single sign-on system. That's done by having a session key or token which is stored as a cookie, and because all of the access requests traverse the Athens domain, that gets neatly around the cookie privacy rules. EduServe have published a white paper just recently describing plans for distributing authentication back to the campuses, as it were, which is where it rightly belongs. providing an interface to the on-campus authentication service and mapping that local ID onto an Athens set of authorization information. And we'll see in a moment why that's interesting. And they've also suggested that they've also produced a roadmap for accepting authentication via certificates. And if I just show you that briefly, the diagram lifted from the Athens white paper shows how, I won't go through this in detail, but you have a data service provider, you have an Athens box on the bottom right, and there's an authentication service on the campus to which Athens refers when an authentication request comes through to it. And as I say, I don't want to try and go through that in detail, but if you just look at the components on the campus in the left-hand vertical box, you'll see a lot of similarity when you see the diagrams in Bob's talk. So the direction in which Athens as a product is heading is essentially now to a three-component system where at the local site you have the authentication service taking place and a mapping to a permission set that's very like a role in some sense, but in a format which is compatible with the way Athens stores this information centrally. In the central domain, the Athens system will essentially keep track of the session and do history, logging, and statistics. And the data supplier will still have a plugin, and that plugin will still have the function of talking to, not to the campus, but to the central Athens management service. So it's essentially still a trusted third-party model with everything traversing the third party on the network, but what has happened is that the authentication has moved back to the campus from the network server, and it now becomes much more possible to integrate local authentication with Athens authentication. Let me compare that very briefly with two other major projects. The first is the Pappy project, which originates from the Red Iris team in Spain. And Pappy has a distributed architecture. In this case, the authentication and the authorization are both carried out at the campus. In other words, the campus has to be trusted by the resource user to do the authorization. That's where the authorization decision is taken. But in its latest version, Pappy has added a sort of federation component in the center, and which makes it start to look more like an Athens model. Pappy is an open source project. Let me just show you Pappy for a moment. Pappy is an open source project, and in quite widespread use in Spain. There are about 20 sites using it. And they're just starting to grapple with the problem of how you scale something up from 20 sites to become a whole national service. And the conclusion is you've got to think much more about a central organization which sets policy and ensures common standards and all of that sort of thing. And just very briefly on Shibboleth, which Bob will tell you all about in great detail in a moment, the Internet to Shibboleth project also has authentication at the campus. So everybody agrees that authentication is a local function and takes place on the campus. And the campus maintains an attribute management and assertion service. The resource owner has software which, when it has to make an access decision, requests attributes from the campus and makes decisions based on the response. And one of the distinctive features about Shibboleth is that it's very strong on user privacy issues. Both the campus and subject to that, the user can exercise control over what attributes are released to what the attribute release policy is to release to particular resources which request those attributes. Shibboleth is architecturally very much a sort of bilateral model where the campus talks directly to the resource provider and vice versa, and there's nothing at all in the center in a software-hardware sense. But again, it turns out that if you want to enlarge the community and federate standards, and federate access management across a group of customers and a group of resource providers, you have actually to think in a collective way about a whole set of policy issues, so that what Shibboleth calls the Shibboleth Club, or now the Shibboleth Federation, is in a sense the central component in Shibboleth. And the more you look at these various approaches to access management, the more you can see common components in all of them. I mean, they nearly all have the same components. Sometimes they're moved around, and something which is at the resource provider in one case is located on the campus in another case. And this has some operational consequences. But essentially, what these various different projects are telling us, I think, is that there's potential to converge on a common architecture and a common middleware layer for doing this. So, to conclude, Athens began as an almost wholly centralized model, but in response to the pressures that are driving it from campuses and so forth, it's now devolving more and more of its functions, and it's now starting to resemble Pappy quite closely. Pappy and Shibboleth both, I would have said, began as designs for bilateral agreements, but as the people think about wider scale deployment and what happens as communities enlarge, the policy element becomes more important and has to be thought about almost as a separate component. So as services expand to the national scale, these policy issues become very important, and if you don't need anything else, and you really need some central management framework, for example, in dealing with commercial publishers. So my message essentially, and it's really a lead-on to Bob to tell us all about the internals of Shibboleth, is to say that I think the prospects for these various projects converging on a common architecture is looking very promising, and obviously that's the solution which we all want, because a single solution is so much more attractive for communities like ours than a multiple plethora of solutions all over the place. Thank you very much indeed.
We have time for a few questions, if there are any. Yeah.
Okay, Alan, this is a new move, a new announcement of web services security. Is also a concept of architecture, of authentication, authorization, auditing, and so on, is based on token exchange and attaching token or key or certificate to the message, or something like it's based on SOAP messaging. Have you looked at this? Pappy is very close, is it? Just first impression.
Well, can I comment first of all on my reading of web services security, to the extent that there's been any publications on it? I mean, it seems to me that the two papers that have been published by IBM, Microsoft, VeriSign don't actually get us very far. I mean, all of the interesting parts are the parts which haven't yet been in any sense specified. And even the one specification which has been issued of the base WS security service itself doesn't seem to me to offer much more than a set of placeholders where you would put things. In a sense, the authorization models that we're looking at here are simpler than a full web services security model, and something which I'm conscious that we're going to have to tackle at some point is, in information retrieval terms, the portal problem. Because when you pass, when a request passes through a portal, and the portal is in some sense asked to act on a user's behalf, the security implications become much more complex. And there's been a lot of preliminary work done in the Shibboleth Project to start thinking about that problem. But to do it properly, it seems to me, actually requires public key technology used in some way or another. I don't know if that's an answer to the question. But
also, my impression, I might talk to different people, that current web service security, WS security is a really only placeholders. Always need to run an environment, also need development environment. It's probably far more years ahead to develop the working infrastructure.
My guess would be that a solid commercial use of web services security is at least a couple of years off. I don't know what you guys think.
Presumably it would be motivated by actually using web services in the first place.
Yeah. Well, sure.
Yes.
Which, hands up for those who are using that today.
Well,
and suffering with the fact that there's no security at all. So it's better than that.
I mean, the Globus folks have got a solution of sorts to the problem of having an intermediate party act on your behalf with their proxy certificate. But it's a bit of a kludge in some ways, I think. I mean, there are some people who think that that's going to have to change in time.
Any other questions for Alan? Nope. Alan, thank you very much. Our next speaker is R.L. Bob Morgan from the University of Washington, and he will be speaking to us about the Shibboleth Project, which I think Alan has done a nice job of giving a lead into. R.L. Bob is a senior technology architect for the Computing and Communications Department at the University of Washington. He is chair of the Middleware Architectural Committee for Education, MACE, which steers the Internet to Middleware initiative. And he's also involved with a number of other standards and collaboration activities, so you see him far and wide, including the IETF, where he's co-chair of the LDAP Revisions Working Group. He's active in the Common Solutions Group, the Network Applications Consortium, and most notably as of late, the Organization for the Advancement of Structured Information Standards, OASIS, where he contributed to the completion of SAML, which also plays a major component in Shibboleth. So, Bob.
Okay. Thank you very much, Michael. I was going to start by asking how many people have heard about Shibboleth, but I don't have to do that now, since everyone has heard about it. I guess the other thing to say, as I speed through my 46 slides, is and skip a whole bunch of them, hopefully just focusing on the picture, is the nice thing is, as I think Alan pointed out well, that at least if we don't have interoperable systems yet, we have interoperable problem statements, and that's certainly a good first step. I think an interesting exercise would be to take a slide each from the several presentations that I've seen here about the scalable authorization problem and combine them all into one presentation and see if they would hang together. I think they would pretty much. There's a whole bunch of things to talk about the Shibboleth Project. Let me try and go very briefly through the motivation. Again, I think it's been well described already that we have lots of relationships that all of our institutions have with lots of providers of all kinds. And increasingly, we need to take our internal security systems, authentication, authorization, account management systems, and try and extend them out. So that's certainly a theme here. If we think about the sort of extensions that we've all done with networking over the years, this is the obvious next step. And the ways that we've been doing that up to now have been primitive but effective. I think Athens is an excellent example of a system that met its needs and provided a lot of services for folks. I'd say certainly the experience in the United States is that we are providing those same services. We are generally using much more primitive methods, almost always based on IP addresses to control access, and there's a wide variety of problems with that. So surely we can do something better. I think something I want to emphasize, and I think I have a slide on this a little later, is that part of the scope that I think has been discussed here in general is web-based applications, and there's a limited scope there already. The content provider problem, access to license resources, is a limited scope within that. Part of our intention with Shibboleth was not to limit strictly to that problem, but to try and provide a system that would cover some other kinds of authentication and authorization needs as well. So here's a list of the basic stuff, and I'll be touching on all these points as we go through. Federated administration, I think, is the key idea there. I think a large part of that is trying to work the business model between somebody providing a resource and a different party offering user information about the users of that resource. There's a range of possibilities there. One is that all users have to sign on directly to the target resource with their identity. The target resource manages all the permissions for that. A different kind of model is one we've talked about here, where user attribute information, which is used to make authorization decisions, is supplied. There are various third-party models where third parties might manage some of this information or actually help make the authorization decisions. So I think it's important as we look at systems to do this stuff to think about the wide variety of business arrangements that really already exist in the real world and the ones that we want to try and support. Because as we talk to people about potentially making use of SHIB, they always come up with new kinds of arrangements that they already have with their customers or their resource providers, and where it's all about sharing pain, and we hope it's not for the technology to decide who has to take which part of the pain. Another key point that I'll say a little bit more about is standards in this space. Certainly, we've made a big commitment to this OASIS SAML standard. We think that it'll be pretty successful here in the next couple of years, and the potential of working with vendor implementations is a good one. Again, federated administration, all about allowing origin sites and resource sites to work together to share the work and authenticate locally and access remotely is the common theme, as Alan mentioned. A big concern for this project has been privacy preservation or lack of privacy degradation as much as possible. Within an institution, it's reasonable to think about authentication always leading with identity, that you have to supply your user ID, the system interprets the user ID, looks up permissions or roles or attributes or whatever based on your ID, and proceeds from there. When you think about accessing a wide variety of systems across the world that might want to take advantage of your local authentication, there's some significant privacy issues there. The library content space, certainly we hear from librarians that traditionally preservation of privacy is important for them, that the idea that a content provider can track every single click that the Nobel Prize winning professor makes is a significant risk. So overall, people would feel much better about the relationship between their institution and providers if if they had control over the attributes that get released, and if ultimately the only attributes that are needed, only the ones that are needed to authorize your access to the resource get sent. If the license, as it typically is in many resource provider situations, is that anybody who's an official member of the university community can get to that resource, then they don't need to know my user ID, they don't need to know my title, they don't need to know my email address, they don't need to know those things, and if I choose not to provide those things, I should be able to get access without providing those things. If a authentication system is designed that my one true permanent user ID and potentially a lot of other stuff just goes every time, then you lose that game. So we wanted to make sure that this system provided those the possibility of those while still allowing user IDs and things to go over when necessary. So the key there from the application point of view is promoting the idea of attribute-based authorization, that in the case where the model is as it typically is, that it's some user attribute that's granting the access, then just because traditional security mechanisms have always supplied identity and allowed the resource to manage the attributes, doesn't mean we have to keep doing it that way. Emphasizing to applications that they can and should operate on the basis of just getting attributes about the user and not necessarily getting permanent identifiers is something that we need to start promoting with our client applications, where just to note, attributes can be simple attributes like member of community, can be more complicated role-based attributes such as the kind of things that the Permis Project is promoting. So there's a whole range of things there that can be covered by attributes. Our starting scenarios were these four. Again, the typical member of campus community getting to license resource that we've heard about, a member of a course. Increasingly, we hear about courses that are put up, inter-institutional courses that want to provide access to licensed resources, media, information, special access to databases and things that are not just okay to put up on the web, and not okay to make accessible to the entirety of the remote institution, but just to members of the class. So we want to be able to support that kind of requirement when it comes in, and not tell those courses that they have to hand out user IDs to everybody in that other class. So, the sort of more classic kind of requirement that is user ID based. If I want to have the members of my working group in Internet 2 or scattered across a whole bunch of institutions be able to get to some access controlled resource on my server, I could just enter their user IDs and put them in. They can in that case make sure that their user IDs are supplied to my service, and that'll work too. So I think we believe that it's possible and useful and important to design a system that can support all these scenarios. The even more interesting one is those of us running central campus IT departments, as I do, often think of our institutions as homogeneous, but if you ask the people in the departments, they view us with the same amount of trust that we view the national government. So they think that it's important for them, for their sub-organizations in our organization to be able to federate with us. So we think that there's sort of an intra-institutional scale that's significant to support here too. Those are our starting scenarios. We started this project a while ago. These dates are, I think, have been revised in the last week or two, and have slightly slipped from that. But we are about to issue a call for participation for our beta program, and hope to be at our 1.0 release, which is essentially working infrastructure components by I think October 1 at this point. But we do have some working code now, and I will be doing a demo here, trying it out shortly, and so we can see how well that works. We are working closely with a number of folks now who are interested in making the system work. A particularly large one is the National Science Digital Library in the United States, a big project to provide access to potentially thousands of science-related resources to millions of the potential users. Some of those are more or less freely available, and they're concerned more about indexing and discovery problems. Some of them have significant license terms and particular communities that have to be managed. So they're trying to integrate that sort of large-scale metadata management and index and discovery problem with access control. And EBSCO is one among several commercial information providers that is interested in working with this system. We've had some pretty good response from that community in the last month or so. And Meteor is the name of a project run out of the Department of Education in the U.S. government that's intending to provide access by students to loan information supplied by lending institutions, banks of various kinds, that is interested in using campus authentication to control access to those resources. So now we have not just the classic academic information supplier, but actual financial institutions that might be taking advantage of the system to allow access. So that raises interesting questions about level of assurance and all that we hope to be able to work through. And then WebAssign is a system that I'll be showing a little bit later that does a simple course management kind of stuff and an outsourced basis. And they have relationships with a number of existing institutions that we're working with on the user side. I think I will skip through most of this text here, just to say that on each side we have a few different components architecturally. We distinguish between the so-called handle service, which is the thing that does the authentication of the user, and the attribute authority, which supplies attributes. So it's again important to be able to distinguish those two functions as part of the privacy management. On the target side, there's again a distinguished component that deals with the authentication piece, a part that deals with attribute acquisition, and a part that figures out where you're that helps manage access to get you back to your campus, and then finally the resource manager. That's the thing that actually uses the attribute information to manage your access to the application. So these are all described in detail in these slides here, which I invite you to review from the site. Here's the picture that I think is better to talk through. So here's a user. They go to the resource. The resource says, I don't have a current session for you. Where would you the key problem to be solved here is getting the browser user, back to the place that can provide the authentication information for them. So we have this component known as where are you from, WAIF, that allows the user to provide that information to the resource. And there's several ways that could happen. I'll be demoing some of those. But in any case, the user ends up back at their home institution. And note, of course, that the user might actually be located anywhere out in cyberspace. They're right back at their home institution with a request that includes where to send them back to. And the handle service then connects to their local authentication system, whatever that is. And again, could be whatever the institution has. Part of the point of the system is to disconnect the remote operation from the local operation. So if the campus has a plain old username password system, that's okay. They can play the game. If they're sophisticated and have certificates or some other, or Kerberos or whatever other fancy scheme they might have, that's okay too. They can play the game. Then once the user authenticates, and if they have a single sign-in system, then the user might not be prompted for anything at this point. It would just be like any other application they would go to on their campus. They would end up back here with this temporary identity known as a handle. And so the key part of the privacy protection of the system is that handle is temporary and not related to any other information about the user. So the handle gets passed to a conceptually separate component known as the Shibboleth attribute requester that deals with acquiring attributes that are associated with that handle. So it makes a request to the attribute authority, and the attribute authority then bases what it returns on the identity of the requesting system, on who the user is that the request is about, and what policies the user or the system administrators have set up about what attributes that user wants to go to that resource. So the key feature of the attribute authority is providing the ability for both users and campus administrators of various kinds to manage those attributes so that the right stuff ends up over here. And so the attributes go there and get used by the application to make its access decisions. So this talks a little bit about the attribute authority. We characterize these things as attribute release policies that get established, potentially by the users. We are drafting up a so-called MyAA interface, and part of the interesting question in the space is we think privacy protection is important, but and certainly it is to some class of users. On the other hand, we don't want the availability of that privacy control to cause the average user to go to a resource and be faced with I'm sorry, I can't let you in because you haven't given me the right information, and have to go back and do a lot of twiddling. So there's a real balance to be found there, and we hope that part of the point of the system is to try and help folks figure out that balance between the default of providing lots of information about everybody to the world, default of providing no information about anyone to the world, where the balance is between what the privacy protection that people find important and the access that they need to do. So another key element of the system, of any system like this, is defining the attributes that are offered by an origin site to the target. So we have defined a few as a starting point that we think is useful. These are based on at least some of them on the EduPerson schema that Internet2 developed. Thank you. So this one that's hard to see is is affiliation here. A member at Washington.edu is an example. Here's an actual identity, what we call EPPN, which is looks like an email address in this case. Get us at Georgetown.edu. An entitlement is in our current thinking a likely to be a URN or URI of some kind that merely indicates some kind of entitlement. I think it's exciting to consider the possibility of integrating something like Permis, where this entitlement now could be an XML structured object that express some complex policy expression. So similarly, other kinds of attributes that are the sorts of things that people are keeping now. Let's see. We intend this stuff to be openly available, and hopefully we'll get that nice open source project buzz here soon. And we are hoping that it and expecting that it will be incorporated into both other open source things, other university things, and potentially in commercial products. As anybody knows, there's lots of buzz in this so-called identity management or federated identity or global internet identity or whatever space these days. We certainly have talked with both Microsoft and more closely with the Liberty Alliance about the sort of technology that they're interested in this space. I'll say a little bit more about the SAML standards. It certainly looks as though the Liberty Alliance companies are going to be basing their stuff on the SAML standards. So we think that's nice. Again, the potential that a university security system could be a peer player with the banks and United Airlines and telecom companies, et cetera, all as identity providers in a big shared federated space is pretty exciting. The idea that at least we can start with common standards to do that is pretty cool. So skipping beyond some of this here. Just to say a word about SAML, I certainly spent a lot of time helping that standard come into being, and it's now essentially at 1.0. It has to go through official ratification by OASIS, but the spec is pretty much frozen and usable. It specifies standard formats for various kinds of assertions, which are the sorts of things that get sent over the wire in the exchange that I diagrammed up there. Again, there's lots of ways you can do this. Many people have whipped up formats for doing this stuff. There's lots of ways to do it. All of the vendors that were involved in that standards effort all have ways of doing that are different underneath and identical conceptually. So this standard just says here's a way of doing that. It's XML based because that's the way that the industry likes to do things these days. It doesn't by itself have any particular connection with the rest of the web services stuff because it's an XML based thing. It is not itself tied to web services. It could be, and we're hoping that it will be incorporated into some of the web services work. So the other thing to say about SAML is that, like any spec, it's just a spec, and to actually interoperate with it, you need a whole bunch of extra agreements. So part of what Shibboleth does, in some sense, is a profile of the SAML technology to set up all the things that you need to set up if you're actually gonna be able to exchange useful stuff. So all those things there. Let's see. I guess an important point is that though we are trying to make the world safe for username and password, which would get us on a blacklist among some folks here, we also think it's important that as client certificates that are useful interinstitutionally get deployed, and some of them are being deployed now, as we've heard other places today, that this architecture not be fundamentally incompatible with that, and we think we've achieved that. If a client cert is offered as the way to authenticate, that's okay too. You can still do attribute acquisition in the same fashion. And certainly the system components here are all going to communicate using PKI techniques to protect their communications. Let's see. Just a little bit about the club thing. We've spent a lot of time working on these club concepts. I think Alan characterized it quite accurately as one way of doing the sort of arrangements that parties need to make. We think it's important to be able to pull away the policy agreements that have to be made from the technology. An interesting bit of this is that SAML provides a place to put in an identifier for the agreement that is made, under which an assertion is being issued, a slot to put that into the assertion that's passed to the other party. We haven't really been used to labeling business arrangements with URIs up to now, and it raises a whole range of questions about what kinds of appropriate things are there with that sort of labeling. What are the nuances of I'm participating in a federation like the UK National Federation, but my arrangement with this provider is slightly different because I have a one-off agreement with them. How do I make those things work together? We hope that folks will help us solve those problems. But this Club SHIB is the one that we are setting up to do an initial set of U.S. universities and potential other players, including European players and some content providers to get started, and it covers the range of policies that we think are useful now. Just lastly, to sum up, the system that we're putting together and that we hope to integrate with some of these other activities we've heard about today is intended to start moving us towards a world where interinstitutional stuff can happen in the same same level as the intra-institutional things that we've been doing for a while. That we can start moving applications to using attributes instead of always using identity. That we can start putting our institutions in the same plane as other identity providers out in the world, and so we just like others are unhappy with a passport-driven world or even a bank-driven world or whatever. We think that a lot of institutions should be able to do this, and part of that is common standards. And I guess that more or less sums up the slide there. I believe that's my last slide, so thank you.
Demo? Back time.
Pardon me?
I was trying to get you to end early to do the demo, so if you want to do the demo.
Oh, demo.
Yep.
Sorry. Let's see. What is it? Alt tab.
Right.
Okay. Demo. There's always something. Okay. Let me do this quickly. We have a page of demos here. So the first one that I'll show is a modification that we made to a traditional interface managing and stuff for list manager, list proc. So now instead of the standard basic auth dialog that I might usually get here, we instead show our form that potentially lets the user select from a bunch of different campuses. So these are the campuses that are part of our Alpha Pilot Club now. I'm going to use the Internet2 example campus. So this will take me from the form at the resource that I wanted to go to, hopefully to, and we're all using fake certificates here for this, so this now is coming from the handle service, which is on a different box, happens to be both in Internet2, but it's a different box. So this is the authentication service at my Internet2 example campus. So I will pretend to be Stephen Carmody and authenticate. In this case with basic authentication. So as part of our debug mode, we let the user see the request that's going to get sent. So right here, it's saying that user Carmody, the handle service knows that to user Carmody, a handle of this thing here, classic UUID, has been issued. So what the target resource gets is just that long string of stuff as the handle. They don't get the user ID to begin with. That goes, and so in this case, this application did make a request, and because it's an application that wants my user ID, because it needs to give me a menu tailored to me, it does know that it's me, and because it's me, or actually Carmody, I can get to a particular resource here. If I had gone in with another user, which I won't take the time to demo, then the application would know that I wasn't authorized as that user, and you would see that I wouldn't get to the resource. So here I will demo something slightly different. We've set up a proxy to the actual EBSCO content service. I am going to go to it as a member of the University of Washington community. So now when I go to that resource here, I see my same form. I get to choose University of Washington. It sends me to University of Washington, and I'm using a fake certificate there too. So that sent me to a handle service that I set up on a box in my office, and here I am redirected to the actual web login screen at University of Washington. So I will authenticate there. Point I'm doing the right thing. Again, same kind of handle request. There's the handle. There's my user ID. In this case, the target is only authorized to see my academic affiliation, my member of Washington.edu. So here's a page that is the same page that anybody from Washington would see, the same page that people get to now because of IP address restrictions or going through a local proxy on our campus. So one last demo here. The WebAssign system that I mentioned before is interested in using Shibboleth to provide access to students, the large numbers of students that they have coming from other institutions who now have to get special usernames and passwords. So in this case, they aren't doing the so-called WAIF interface. They generally set up a page for each institution that they work with. So now I'm coming in as someone from Penn State, and I would just know that I'm supposed to go to this Penn State page to see whatever information they want to give to me. So now I don't have to, essentially the where are you from thing has happened up front just because that's the way this system is, user interface is designed. So I just click student login here, and now so this prompt is coming from a machine at Penn State, and I will type in the username and password that they sent to me, and again my handle request, and now I am at WebAssign they, in this case, again, they had access to my user ID via the attribute acquisition there, and can present me with the page that's tailored to me. So. Again, with WebAssign now, I would have had to enter. They would have had to administer a separate username and password for me. Now, they can rely on the service from that institution. So, I believe that's all for the demo, and we're probably already past time. But I think,
we're okay.
Oh, I see. You were just you were tricking me.
So if there are any questions for Bob at this point, I will note that, as we all know, most demos fail, and these did not.
Right. So.
Yeah, I've got one question from listening to the last small number of presentations here. I seem to get the impression that most of the activities focus on web-based interfaces and web-based applications. And sort of my question is my feeling correct? Is this sort of some sort of hidden assumption and agreement amongst your trade that this is the way to go?
Yeah. So why is it that we just care about the web? Well, if you've looked around, you've noticed that the web tends to be pretty important, and that a lot of that, in particular, for the sorts of targets we're talking about, my institution accessing remote resources, those more than other things, I think, tend to be accessed via web browsers. I don't tend to use my calendar or email client, to go to remote places. There are obviously important applications that are that need to happen inter-organizationally. Video conferencing is kind of the main one that we've been focused on in Internet 2, and working with a number of folks on that interinstitutional authentication authorization problem. I think we still hope that we can apply at least some of these web techniques to that, but it isn't clear how much they cross over. A lot of the features that I just showed are specific to the way web browsers work, the whole redirection thing, and being able to put up a form where you can enter username and password, that kind of thing. Does that undercut the utility of this? I think somewhat. Does it? Would it be a better world if everybody had certificates that could be applied across all applications for all time? Well, yes, but certificates alone are not, are well. I mean, I don't need to go into issues of certificates, but is this an important enough problem space that it's worth trying to promote this technology? I guess we think it is.
I think we have an additional response here.
Yeah, in my view, authorization is a sufficiently complex problem that it's an open question still as to whether one scheme is going to solve everybody's needs. Right now, the grid folks certainly would not be happy with a scheme that was web-oriented only, and they're looking at authorization schemes which equally would not solve these problems.
I certainly appreciate sort of the impact you could make with solving the problem with the web-based environment. And I guess this approach is very appropriate as long as you have a well-structured user community, like a sort of a pretty small set of information providers and a pretty large consumer community, and where the individual roles are well defined in either being an information provider or being a consumer. I'm sort of thinking about situations, in particular in a university, where these roles might be might tend to be mixing somehow. That an individual or a researcher or someone working in a particular department or project might be a regular consumer of some set of services at the same time when he or she is sort of a provider of information in the framework of a project. And then one of the potential approaches could be sort of to recommend to those people to run a web server which is enabled with that technology and sort of do whatever is required to double quote misuse double quote the well-established web technology to provide the authentication and all that machinery, and try to do sort of some sort of plug-in or forwarding thing to different applications. I mean, I'm deliberately stretching sort of the limits here a little bit, but
right.
It seems to me like if we would not have DNS at the moment, but we would have had the web technology at that point in time, we would be building DNS just for the web, and we would not be able to use name-to-address translation for any other application. That's deliberately stretching it, but it's sort of just to get my point across.
Right, no, it's a good point. It's a good point. Well, I think you're right that we do see people doing, pragmatic things like putting web interfaces on, other kinds of resources. I mean, my classic example is the one that we recently deployed at my university to manage access to wireless networks. You authenticate with your web browser to the access point, and then it gives you access. Like, well, why is a wireless access point a web application? Well, it's not, but it's the least common denominator. So if it's reasonably effective. Again, I think we all can appreciate that common universal security infrastructure is desirable, but if it were easy, we'd have one already.
Okay, so. I know we've gone over a little bit, but one more comment or question, and
I just want to endorse that comment about once we have a tool that works in web services, we're going to be sinfully tempted to use this tool for non-web-based services, and we are at that point right now with desktop video conferencing, where we've been trying to sew authentication and authorization and resource discovery into desktop video conferencing. It is the primordial non-web-based app. And we feel in the long term that SAML expressions can be carried as payloads in the setups for both SIP and 323, but we don't know how to do it, and we may succumb to temptation and say, let's put a web app in front of this just as a pilot to incent people to understand the value of what authenticated, authorized video conferencing can do.
Okay. I'd like to thank all of our speakers. I think they did all a wonderful job. Thank you. I would like to remind you that tomorrow for lunch it will be Meet the Speakers, and you can ask questions of both Bob Morgan and Alexander Otenko. And a reminder that 4 o'clock we begin again for the last session on directories, and we will now break. Thank you.